So we're all getting pretty comfortable handing over bigger and bigger parts of our digital lives to these powerful new AI assistants, right? But what if there are some really surprising dangers lurking just beneath the surface? I know, it sounds like something straight out of a sci-fi movie, but this question is getting more real every single day. So what really happens when the tool that's designed to help you turns against you? Let's break it all down. Okay, to really understand these new AI agents, we've got to start with the technology they're actually built on. And it all begins with this idea of a digital workforce. At the very core of this is something called robotic process automation, or RPA for short. Now, just think of these as little software bots. Their entire job is to mimic what humans do for all those boring, repetitive digital chores, like data entry or processing the same transaction 1,000 times. The goal is simple. Let the bots handle the monotonous stuff so we humans can focus on the more creative, critical work. But here's the thing, we are moving way beyond just simple automation now. So let's actually peel back the layers and take a look at the anatomy of a next-generation AI agent that's taking this whole concept to an entirely new level. So meet OpenClaw. This is a seriously powerful autonomous agent, and it absolutely exploded in popularity. I mean, it gained over 100,000 stars on GitHub in just 2 months. This kind of viral growth shows us that there's a huge appetite for these tools, but it also means that thousands of people adopted it almost overnight, which creates this really fascinating mix of incredible hype and some pretty serious hazards. And here's the key thing to get your head around. OpenClaw isn't just a chatbot you talk to. It's what's called a headless agent. Think of it more like a background program that just lives on your system 24/7. It's got this proactive pulse where it wakes itself up to get tasks done without you ever having to ask. It's designed to be your persistent, always-on digital manager. And that persistence, that autonomy, well, that's exactly where these hidden risks start to pop up. Because when you have something that's always on and always has access to your stuff, the potential for things to go wrong just multiplies. We can actually break these dangers down using a handy model called the RAC Threat Framework. It basically categorizes all the threats into 3 main areas: root, agency, and keys. Let's take a look at each one. First up, we've got agency risk. This is sort of the black box problem. It's where a perfectly valid command ends up causing total destruction. So imagine telling your agent, hey, clean up my downloads folder. Sounds simple enough. Well, the agent, in its infinite digital wisdom, might just interpret clean up as delete everything. And this is real. In one case, a user watched as over 11,000 files were wiped out in seconds. The command was valid, but the consequence was absolutely catastrophic. Next, there's keys risk, which is basically a fancy term for credential theft. Think of it like having a leaky pocket. To connect to all your services like Slack or OpenAI, these agents need your secret API keys. And you'd think they'd be stored securely, but nope. A lot of the time, they're just sitting in plain text files. And there is actual malware designed specifically to scan your system for these files. So if your agent gets compromised, we're not just talking about one password. Your whole digital identity can be stolen. And finally, we have the most severe one, root risk. This is a total machine takeover. A critical vulnerability was discovered in OpenClaw that acted like a wide open door. A quick scan found over 5,000 exposed systems online, just sitting there, allowing attackers to execute any command they wanted on users' machines, with no authentication needed at all. This is called remote code execution, and it's pretty much the digital equivalent of handing a burglar the keys to your house. Okay, I know that all sounds pretty scary, but it's not hopeless. After these risks came to light, the security community developed some really powerful ways to contain these agents and, tame the beast. So let's look at how to build a proper defense. The best solution is to build a kind of digital cage using 3 key layers. First, there's containerization, which puts the agent in a sealed box so it can't access your entire file system. Second, you have brokered authentication. This uses a secure vault to give the agent a temporary pass instead of the master key. And third, there's perimeter defense, which acts like a firewall, blocking unauthorized network access and basically locking the cage door. And for us, the actual users, the best practices have been boiled down into this, the Sovereign Agent Manifesto. It's just 4 simple rules. 1, isolate. Always run the agent in a sandbox, never directly on your main computer. 2, verify. Check the code of any new skill you're about to add. 3, broker. Use a vault for your API keys. Don't just leave them in config files. And 4, monitor. Watch the activity logs. Look, OpenClaw offers this dream of a digital employee. but in its current state, you have to be its security officer. But this is where the story takes a really fascinating and unexpected turn. It turns out the risks aren't just technical, they're also social. And the solutions, well, they might be social too. So this leads us to a really profound question. We've been focused on just one user and their one agent, but what happens when thousands of these autonomous agents all start interacting in a shared social environment? Welcome to Moltbook. It's a social network built exclusively for AI agents. That's right, no humans allowed. Here, more than 14,000 OpenClaw agents post, comment, and interact with each other, creating a completely unique digital society all their own. Researchers who were analyzing this network found something truly remarkable. They discovered that 18.4%, so nearly 1 in every 5 posts, are action-inducing. What that means is they contain direct instructions, commands, or code for other agents to follow. Sharing instructions isn't just a weird quirk, it's a routine behavior. So how do other agents react to all these instructions? This is where the most surprising finding emerges. When an agent posts potentially risky instructions, the social response actually changes. If you look at this chart, you'll see endorse comments slightly decrease, but enforce comments, where agents are actually cautioning against the behavior, they increase. I mean, this is profound. The agents are developing their own social norms, completely on their own. They are selectively challenging risky behavior, creating this form of decentralized social regulation without any human intervention or centralized moderation. In a very real sense, they're policing themselves. Which leaves us with one final massive question to think about. The dangers of a single rogue agent are pretty clear, but the emergence of entire agent societies, that opens up a whole new frontier. If AI can build its own societies, governed by its own emergent norms, what are the rules, and who gets to write them?